Thank you and welcome. And congratulations, because the Electric Universe conferences are perhaps the only real conferences to come to if you want to learn about science. So I congratulate you on having the initiative and the curiosity and the open-mindedness to come here and also to be involved in the live streaming of this conference. Annis's talk actually was a very good introduction because I wasn't going to say a great deal about this long path to understanding gravity. The early days, my story, started after I read Velikovsky's Worlds in Collision as a teenager. This was before going to university. When I got to university, I thought this was an ideal time to ask questions of lecturers and try and interest other students in the subject. I was amazed at the lack of interest on the part of most people, and also the sometime hostility of lecturers to being asked questions that they couldn't answer. This caused me, as a science undergraduate, to look in the shelves of the library in the sections on the myths and legends and stories of peoples from around the world. And it was there that I became convinced that Velikovsky had made a leap forward, and he'd posed questions which must be answered. They couldn't be ignored. The response, of course, of the astronomy community was that what Velikovsky proposed, that Venus was a comet, that Mars moved close to the Earth in historic times, was absolutely impossible. It disobeyed Newton's law. So it was in 1979, long after, I visited Velikovsky at his home, and my question to him was, and this was based on the hostility towards his idea that he could break Newton's law, what is it we don't understand about gravity? And he was kind enough to give me a slim volume where he had written, back in the 1930s, Cosmos Without Gravitation. And in that, he actually looked at the behavior of matter in trying to produce gravity. And this is quite distinct from the way it's being done right now, which is mathematical, purely mathematical. So that gave me an idea, and also I had formed the opinion that science had left the rails 100 years ago, and that to regain the path forward, the path of discovery, we had to go back to get to the future. We had to go back to the classical physics approach, the great experimenters, those who had intuition about the behavior of matter, and also to revisit Newton himself. It was only 2 years after that, in 1981, that I was reading the Scientific American, and there was a tiny advertisement by a chap called Ralph Sansbury, who was publishing the Journal of Classical Physics, which immediately caught my eye, and the first topic was electron structure. Now, according to particle physics, an electron has no structure, it's a fundamental particle. But that's a mathematical concept which has no physical reality, because if you try to reduce an electron to a point particle and give it charge, you end up running into infinities. And of course, once you do that, the theory breaks down. Scientists have a way of getting around that these days. They call it renormalization, where when your theory breaks down, you open the window, see which way the wind's blowing, plug that into your equation and keep going. They do that repeatedly for theories about the sun. So, what's the situation today? And this is a statement by Martin Rees, the former Astronomer Royal and Fellow of the Royal Society, well-known figure. It's one of the few things I agree with that he has said. He asked the question, what causes gravity and mass? these questions still baffle all of us. Rather than the end of science being nigh, in other words, we're almost at a theory of everything, we are still near the beginning of the cosmic quest. And I agree with that. Also, Richard Feynman has said, there is no model of the theory of gravitation today other than the mathematical form. And this, I think, when you watch shows on television about the mysteries of modern science, it's all about mathematics. While I was flying over here from Australia, I watched the show by Morgan Freeman on the mysteries of the universe. And that just devolved into a show of mathematical equations that no one understood. And it ended up with some guy saying that reality is just mathematics. Well, this shows how far away we've moved from classical physics, experiment, observation, testing of ideas, and verification by experiment. So, mathematics isn't physics. The guy on the right in that picture is Peter Higgs. I call him the $15 billion man because I think that's what the Large Hadron Collider had cost up until a year or two ago. Just a moment while I get my screen to give me what I want on the... That's better. So the first step on the path to discovery is to find where we left the path and got lost. As I said, it happened a century ago. Now, pictures like this are the favourite media cliche for genius. Have you noticed? It's an illusion. Now, Peter Higgs, the whole reason for the Large Hadron Collider was to show the existence of a hypothetical particle called the Higgs boson, which was supposed to give all other particles, the ones that make up you and I, mass. That's the most incredible nonsense idea I've ever heard. The particles that make us up, we know have mass, and they contain energy. An atom bomb tells you that. You can see the energy released by those particles when they're messed around with. They must have energy, they must have mass themselves. It's got nothing to do with something outside. So what gives matter its gravitational mass? And mass is measured by its weight. So the phenomenon of mass relies on understanding gravity. You push or lift a mass and the mass is the same. Why is that so? Whatever the mechanism involved, it must be the same in both cases. And when you push something, what's happening, really? It's the outer electrons in your finger and the outer electrons in the object that you're about to push that are reacting to one another electrically. It's the electric force. So, particle physics is in as big a mess, I would suggest, as astrophysics. It's completely lost the plot. They say particles are made up of quarks. That's apart from the electron, I should say. But these quarks you can't see because, why? We're told they're confined within the nucleus, so you can't see them. This is a typical trick of both astronomers and planetary scientists who, when they're explaining where magnetic fields come from, it's always hidden out of sight inside the body. There's no concept of it being due to something on the surface or exterior to the body. So the Large Hadron Collider didn't confirm the Higgs boson concept. It found something. Whatever short-lived matter resonance it hinted at has nothing to do with the question of why matter has mass. It's totally irrelevant. The answer has to be found in the structure of matter itself, not some external cosmic treacle particle called the Higgs boson. Meanwhile, gravity is lost in the mystic rubber sheet of a non-physical fourth dimension. You've all seen that picture of the rubber sheet, which has got a heavy object on it, and so it sort of forms a funnel. That's using gravity to explain gravity, because you will not form a funnel unless gravity is pulling that mass downwards. What's more, This is supposed to be warped space. Nothing is going to fall down that hole if you were to place it on that funnel. There is no force involved. Space can't exert a force. So, here's an equation. Everyone, I think, has seen it. It's the most easily identifiable equation in physics. What does it mean? It says that energy is somehow tied up in matter, but energy and mass are undefined in terms of matter. So what does mathematical equality mean? This is the point. An equation is a way of describing reality, and it's a shorthand. Unless you know exactly what those symbols mean and what they entail, you cannot even explain what the equal sign means. That's a mathematical symbol. What does it mean physically? If you haven't got an answer, you have no understanding, and that's the situation in physics right now. And instead we witness this crazy search for a mythical boson beast to impart mass from outside. Clearly, what this equation is telling us is that energy, mass, and the speed of light are all properties of matter. You have to repeat that until it sinks in. And of course, when I say that, it means that the speed of light depends on a medium. If there's no medium, there is no light transfer. It's not possible. And C is supposed to be a universal constant, one of these physics constants. But it depends on the medium, which means the vacuum is a medium. And Einstein did away with that medium. He discarded what they called the ether. That was the medium through which light was supposed to move. Maxwell's equations require it. Einstein discarded it and never said how he could do that and get away with it. It's been found that the speed of light is not a constant. It varies. So what happened? They now define the meter in terms of the speed of light, so they forced it to be a constant. So even though an equation works, it describes reality sufficiently so that you can build things and do science, so to speak. Unless a physicist can explain the meaning of each symbol and operator on the board in real physical terms, plain language, the equations remain merely descriptive with no real meaning. Newton was honest. He said he had no explanation for his law of gravity. However, he made the mathematician's mistake of raising it to a universal law. In that way, the math game can continue and you can invent dark matter and black holes or any other unobservable fairy at the bottom of the garden to keep the fictional story alive. And this is what's happened. So we don't understand gravity. Newton described it with his equation, force equals the gravitational constant, big G. You multiply that with the masses of two objects. The question is not answered. How does this mass know about that mass? How can this be so? And the equation says you divide by the distance between them squared. And it works. I mean, NASA uses this equation to navigate the solar system. You'll note that it's the same form as the electric force. You just substitute there for the masses the two charges. But as we saw yesterday with Jerry Pollack's talk, that force is enormous compared with the gravitational force. So this suggests that mass may be understood electrically. If you can substitute charge for mass and you come up with an electrical force, then perhaps mass can be understood electrically. So to understand gravity, we must understand why matter has mass. And as I pointed out with the Higgs boson, they've got no idea. You'll notice that Newton's equation does not refer to time. It's instantaneous. And this is glossed over. In the electric universe, however, this instantaneous connection is absolutely essential for coherence, for coherence of atoms, so that they're stable particles, for coherence of planetary systems, so that the Earth knows where the sun is right now, and in galaxies, so that you can form a spiral. If the stars on one side have no idea where the other stars are until 100,000 years later, how do you form a beautiful spiral? And even at the subatomic level. Now this universal gravitational constant, big G, has the peculiar dimensions, and this is a mathematical term, it has nothing to do with the three dimensions of space, of length, mass, and time. But time has no length or direction in space. This is where you can get this confusion when the word dimension is used. And you get into all sorts of mystical talk. In fact, I would suggest that it was science that started the kind of New Age ideas where people talk about extra dimensions and so on. In the electric universe, there's no need for that. The universe can be as wonderful and mysterious as we observe in the three physical dimensions we have, but that goes much deeper. So G actually should not be a constant because it refers to mass, and as I said before, mass is the energy tied up in a particle. It's an electrical variable. So G is not universal. That means that big G, which we measure on Earth, is neither universal nor a constant, and in fact it's the worst defined constant in physics. Every time it's measured, it's different, and even using the same equipment, it varies. So what I would suggest is there is more complexity in the effects attributed to gravity. I say attributed because in some cases we're looking at actual electromagnetic forces, and I'll talk about that, and it's mistaken for gravity. It has more complexity than any equation yet devised can explain. It depends on the context whether it's actually valid or not. It's not universal. We repeated the mistake of Earth-centrism. In other words, we measure G on Earth and then apply it throughout the universe. What gave us the right to do that? So we have selective blindness towards conflicting evidence, and we invent dark matter and dark energy, all this stuff. And for example, these pictures that I've got here, and as Anna's said in her talk, we ignore the fossil record of impossibly huge creatures. The ultrasaur, in today's terms, would have weighed 180 tons. And the maximum force exerted by any muscle is independent of body size and is the same for the mouse as the elephant. In the antediluvian world, 350-pound flying creatures soared in skies which no longer permit flying creatures above 30 pounds or so. And the ultrasaur's neck in today's gravity would have caused a 430,000 foot-pound torque where it attached to the body. Even a steel girder of the same mass as that neck would have sagged under that weight. Also, we know observationally that spacecraft show anomalies in Earth flybys, and comets exhibit what's called non-gravitational forces. That's what makes them difficult to predict their returns. And people who have measured gravity, or the change in gravity as you go down deep mine shafts and so on, actually said it looks like there's a fifth force. It's not changing the way we expect from Newton's law. And people who have measured gravity going up towers have said maybe there's a sixth force because that doesn't conform to Newton's law either. It was pointed out to me a few months ago that if you calculate using Newton's law the force of the sun on the moon and the force of the earth on the moon, when the moon is between the earth and the sun at new moon, the sun is pulling on the moon twice as strongly as the earth. And the question is, well, how do we have the moon? It's a good question. None of these questions are answered by Newton's simple equation. Of course, if big G is universal, If we use G measured on Earth's surface, the comet 67P looks like solid rock, while its density appears to be that of highly porous dust and ice. And I have repeatedly in the Space News on the Thunderbolts website pointed this out. The planet Saturn appears to have a lower density than water. It could float in water according to using big G as we measure it on Earth. And the composition of the Sun is calculated to be mostly hydrogen right down to the very core. Now, what body the size of the Sun would have hydrogen gas in its core? If you were to look at the Earth and if its ionosphere was lit brightly, rather like the Sun, and you saw oxygen and nitrogen and so on in the atmosphere, would you say that the core of the Earth was then oxygen and nitrogen? No, you'd say more likely to have heavy elements. Michael Faraday. And this is where we get to the principles of classical physics, and that is that good physics needs to be simple. If I can't explain to you in physical terms what I'm talking about, and simply, then you have every right to go and ask somebody else. Michael Faraday, the great experimentalist, could see the possibility of an electrical nature of the force of gravity. Remember I said that two equations are the same form. And he wrote, "The long and constant persuasion that all the forces of nature are mutually dependent, having one common origin," that's the electric universe position, "or rather being different manifestations of one fundamental power," once again the electric universe idea, "has often made me think on the possibility of establishing by experiment a connection between gravity and electricity." And he went on to say, "No terms could exaggerate the value of the relation they would establish." Precisely. Now, if people had followed Faraday's intuition, we would be several centuries advanced, I would say, in our science. But of course, this poses the key question. The electric force is both attractive between opposite charges and repulsive between similar charges, but gravity seems to only attract. Why is that so? And here's a character who was around at the time of Einstein. Sir Oliver Lodge was a British physicist and writer best known for his contributions to the development of wireless telegraphy. He perfected a radio wave detector and the heart of the early radio telegraph receiver. He was the first person to transmit a radio signal 1 year before Marconi did, and received international recognition for his work. Lodge is also remembered for his work on the ether, which had been proposed as the wave-bearing medium filling space, and of course, which the electric universe relies upon. Other scientific work included investigations on lightning, the source of the electromotive force in the voltaic cell or battery, electrolysis, the application of electricity to the dispersal of fog and smoke. He also invented electric spark ignition for the internal combustion engine. He was a practical man. Rather like your Faraday, he was prepared to experiment and try things. He was critical of the new theories of relativity proposed by Einstein. I would suggest that if education was done properly, his arguments against Einstein would be placed against Einstein's arguments and students allowed to judge for themselves. Referring to Isaac Newton, he wrote, "What is really wanted for a truly natural philosophy is a supplement to Newtonian mechanics, expressed in terms of the medium which he suspected and sought after but could not attain, and introducing the additional facts, chiefly electrical, especially the fact of variable inertia discovered since his time." That was in Nature, Feb 17, 1921. Lodge seemed to be fully aware that Newton's mechanics needed to take into account electrical effects on the masses involved. This is a pivotal idea for gravity. Understanding gravity is essential to be able to express mass in terms of weight in kilograms. So here was a guy, another one, who was well on the way. Once again, good physics needs to be simple. Sir Oliver wrote, "It may be that when the structure of an electron," remember at present it has no structure. Once it's understood, we shall see that an even-powered stress in the surrounding ether is necessarily involved. What I do feel instinctively is that this is the direction for discovery, and what is needed is something internal and intrinsic, and that all attempts to explain gravitation as due to the action of some external agency, whether flying particles or impinging waves or Higgs bosons, he could have said, are doomed to failure. He's probably spinning in his grave at the waste of the LHC experiment. He showed insight and uncommon sense with his idea that the electron must have structure. All subatomic particles must have a charged subparticle structure and orbital motion to have self-energy or mass, and exhibit magnetic polarization, which is called confusingly spin by particle physicists. This is where language gets into the way of physics today as well. Now, if we're going to talk about particles and matter, we have to look at the scale of the atom to give you some idea of what we're talking about. The first step, then, is to give some idea of scale. As I said before, modern particle theory is no help because specialists were still arguing over what is really real in nature last month. This picture gives an idea that the classical atom is mostly empty space, with the charged particles invisible on this scale. It is easy to see how an electron orbiting the nucleus can only shield the nuclear charge from a nearby atom for a fraction of the time it takes in its orbit. Because at some points, or most of the points in the orbit, the proton, for instance, the charge on the proton is visible to a nearby atom. And the same thing for the other atom. So it gives you the idea that if those two atoms can synchronize their orbits, they can then come together and form a molecule. So, as it says there, if the nucleus was the size of a ping pong ball, the electrons would be the size of a flea orbiting outside this stadium, which is in Melbourne Cricket Ground in Australia, one of our famous institutions. Here's another guy. You don't hear about these people. I think Newton said that if he'd seen far, it was because he'd stood on the shoulders of giants. I would suggest that you have to be very careful in your choice of giant because he may be facing the wrong way. These are the people who should be in our science education curricula. Fritz London was a philosopher of science, a visionary logician and dedicated theoretician. In 1930, Fritz London explained the weak attractive dipole electric bonding force between atoms, known as the van der Waals dispersion force, or it was named after him also as the London force, which causes gas molecules to condense and form liquids and solids. In other words, planets and you and I and everything in the visible universe. The London force originates in oscillating electric dipoles caused by slight distortion of otherwise electrically neutral atoms. So here we're talking about the kind of stuff that the Earth and the planets and the sun that are made up of. The tiny electric dipoles arise because the charges within the atom are separated, as shown in the last slide, by effectively a huge distance. The electric dipoles resonate, as I said, they sort of tune into each other and orbit in such a way that they combine. It's always attractive, just like gravity. So there's a clue. So, in fact, Fritz London said that it seems that gravity may be this kind of interaction between neutral matter. So it seems that the clue about the real nature of gravity has been available to chemists who are not interested in gravity and unavailable to astrophysicists who are not concerned with physical chemistry or electricity. Obviously, gravity has the distinction of being much, much weaker than the force between atoms, the London force. But that should be a clue. We are bonded to the Earth by a similar but far weaker version of the London force between atoms. And here we get into the idea of repeated patterns in the electric universe. So like gravity, the London force is always attractive and operates between electrically neutral atoms and molecules. Very much like gravity. So we talk about matter and mass. So the second step on the path to discovery about what gravity really is to look at the particles that make up matter. Newton's law multiplies the masses of two objects together, so the first requirement is to define what is meant by mass. The electron is defined as a fundamental indivisible particle, but it must be a composite of smaller orbiting charged particles, shown here in blue, to store energy. The energy is stored by the motion of those charged particles with respect to one another and also with respect to all other particles in the universe. The same goes for all subatomic particles. Doesn't matter what it is, including the neutrino. The neutrino also is included. And there was a report that I got yesterday that they have now shown that the neutrino has mass. Now, the very idea that it didn't have mass meant that it couldn't have been a real particle anyway, because there was no such thing as a particle with no mass. The problem then was that, according to the standard particle, or standard model of subatomic particles, the neutrino doesn't interact with the Higgs field, as it's called. That meant that there was something seriously wrong with the standard model. So what has happened? They've said, this gives us the opportunity to modify the standard model. In other words, please send more money. The electron is defined, as I said, as a fundamental indivisible particle. And it goes for all subatomic particles. And this simple repeated atomic model is at a far smaller scale. You remember the ping pong ball in the middle of that ground and the flea on the outside? That means that within those tiny objects, there's also spinning charged smaller objects. Who is to say where we stand in the cosmic scale of things? Now, Ralph Sainsbury, who was the fellow I mentioned earlier who published this idea of electron structure, showed that you could actually derive the magnetic force from this structure. In other words, it's a version of the electric force, and gravity from this structure. It's another weak form of the electric force. So here we are, we're doing what classical physics was designed to do, simplify. Now they hand out Nobel Prizes for inventing more forces and more particles, and we know less and less the more they do that. Ralph Sainsbury, though, said if you calculate the speed of these orbiting little subparticles inside the electron, it's phenomenally faster than the speed of light. He calculated that if those tiny little subparticles were to be released from the electron, they could travel from here to the far side of the Andromeda galaxy in 1 second. This comes back to Newton's law, which doesn't involve time. In other words, it says it's instantaneous. Well, that kind of speed is instantaneous on our scale and on a galactic scale. Tom van Flandern did his own astronomical calculations to point out that the Earth orbits the Sun and it knows where the Sun is right now. And it's fairly easy to determine that. And by using a more stringent test, he calculated that the speed of gravity exceeded 20 billion times the speed of light. So the difference between that and Ralph Sainsbury's was about the order of 1,000 times. Ralph Sainsbury's is probably more accurate. So the electric force between matter, particles, must operate instantly on our scale of things for the electron to be stable. That something comes out of this is that once you have the speed of information exchange almost infinite, then time is universal. time has nothing to do with Einstein's clocks. Clocks are physical things. They're made up of atoms and so on, and their environment can change the way they tick. So to use the clock as a surrogate for the concept of time was completely inadmissible. So Einstein's special theory of relativity, I'm afraid, is discounted immediately. So, Newton was right. Gravity is effectively instantaneous. And Einstein strayed from the path to discovery by postulating the speed of light as the maximum speed for information transfer. When he did that, he disconnected everything. He made an unworkable universe. To have a workable universe, all of the components of the universe must know what all the other components are doing in real time. The difference between this idea and Einstein's is rather like you drop a pebble into a pond and you pick up the sound wave, which is a compressional direct wave. It's much faster than the ripple itself, which takes time. Light is a ripple. It takes time to pass through the ether, the medium, to the receiver. That's enough of that. With the real meaning for mass, we can attempt to give real meaning to energy as represented by the equation that everyone has seen but no one understands. Energy is charged matter in motion relative to the charged matter in the rest of the universe. That's the first physical definition I think you'll ever see, because if you look up encyclopedias and textbooks, they give examples and how one changes from one form to another. They don't actually explain at a fundamental level what it is. That's that one. Electromagnetic energy is stored in the resonant orbital structure of all subatomic particles. It's matter in motion. And the mass of a particle is a measure of how much energy is absorbed internally in its deformation rather than its acceleration. It's rather like having a balloon full of water, and you poke it, it resists moving and deforms instead. Well, these particles do the same. And this is why what was his name again? The chap earlier who I mentioned, he said that we had to look at the electrical, or the idea that when you put electrical energy into a particle, like in a particle accelerator, the mass of that particle seems to change. It's that concept that you really had to focus on. So what causes gravity? The gravitational mass equals the inertial mass. That's lifting and pushing. So much the same mechanism is responsible for gravity. Now, atomic electrostatic dipoles, as I've talked about with the London force and so on, are formed by most atoms inside the Earth with the inner pole positive and the outer pole negative. The reason is that gravity is pulling on the nucleus. You can't shield gravity. That's the point. So the fact that the electron's down there doesn't matter so much, except that it holds the nucleus back from moving in the gravitational field. The nucleus is about 1,800 times heavier than the electron. So if it moves in the direction that gravity is pulling it, then the atom is distorted, as I've shown there, which means that the bottom end of that atom is more positive than the end nearest the surface, which is more negative, simply because the electron spends more time out at the top of the curve and a short amount of time at the bottom. So, the electric field produced within the atom distorts the subatomic particles. So, the particles within the atom, the nucleus and the electron, are all distorted similarly by a very tiny amount. And this is the distinction between the gravitational force and the electric force. The amount of distortion is infinitesimal. 10 to the minus 38, 10 to the minus 39 times the gravitational force. So, it is the sum of all of the aligned subatomic dipoles that produces the profoundly weak force of gravity. And the fact that they're held by the molecular forces, which is far stronger, means that The atom can't move, the nucleus just sits there and everything's in balance, but there is this weak electric dipole force which is transferred through the body. And gravity cannot be shielded electrically because this dipole force, it's like a whole string of magnets. And if you have a string of magnets on a slippery surface and jostle them around, they'll all connect one to the other, a chain of them. And this is exactly the similar process here. Now, here we go. Gravity has two poles like a bar magnet. And this answers the question about why is gravity always attractive? It's because we stand on the surface of the Earth. And this is the third step on the path to the discovery. Gravitationally induced atomic dipoles set up an internal gravitational field that is weakly repulsive. You've got all of the positive ends of these dipoles facing one another inside the Earth. So on stars and planets, the attractive force between atoms is strong enough to hold these tiny dipoles in place. They can't fall. And so the internal pressure inside these large bodies, like planets and so on, is relieved. There is a kind of anti-gravity effect inside, and this is probably why measurements taken down deep mine shafts don't conform to Newton's law. All stars and planets in the universe repel each other with an inverse square law force because this is like a charged particle. It may have significance for understanding charged particles themselves. It suggests even lower levels of structure. Now this is interesting. I mean, all stars and planets in the universe repel each other. Newton's attractive force has a limited sphere of influence. This may explain many anomalies. In fact, as I mentioned, the mines and towers and the fifth and sixth force, the complex structure and odd features of an inner core found inside the Earth by seismologists may have an explanation based on such a model. This is very recent. They found this odd structure to the inner core of the Earth. We're part of the Earth. It's like the molecular force at a very low level. The fact that we're attracted to the Earth is the same process, but at a different scale. We're bonded to the Earth by the dipoles induced in us, the effects like that of a magnet on an unmagnetized steel ball. We therefore assumed that gravity is always attractive. And also it's a mistake to assume that G, measured on Earth, is a universal constant. It depends on the polarization of the Earth itself. And that can be varied by adding or subtracting charge from the surface. The mass of a body varies with its surface charge. So when the thunderbolts of the gods were hurtling around and the planets were on orbits which meant that they came close to one another and enough to exchange charge strongly, the masses were changing. So gravity repels. This is an odd idea, but it's not new. In fact, Newton considered it as a possibility because there was a theory which seemed to work. A pushing theory of gravity was originally proposed by Newton's colleague Nicolas Fatio de Douillet in 1690 and later by Georges-Louis Lesage in 1748, a long time ago. They said that an omnidirectional flux of small particles permeates space and tends to push objects together, and because they mutually shield each other, it gives the effect that looks like gravity, and mathematically it works. It was known later as the Fatio-Lesage theory and was considered seriously by many scholars, including Newton, but was discarded for very good reasons. If you have particles impacting a body, you're releasing energy, and the energy to keep the Earth in orbit around the Sun would have been enough to vaporize it. However, more recently, let's catch up here, Halton Arp, also known as the modern Galileo, discovered intrinsic redshift of quasars, and Anna's talked about that. And he came up with, once you get rid of this redshift equals speed of recession, which gives you the distance. Once he got rid of that, he found out that the universe was fairly static, but then he had a problem. If it's static, how can that be so if gravity is an attracting force? Everything should be falling in towards one another. But he didn't observe that. So he actually, as he said here in this paper, he had an observational requirement to consider what he called Lesage gravity, this pushing gravity. He said, for many years I never questioned the obvious fact that the masses attracted each other. The attraction was so blatant that it required no thought. And this, unfortunately, is the situation in astronomy right now. It requires no thought. But then observations of galaxies and quasars forced me to accept the fact that extragalactic redshifts were primarily intrinsic and not the result of recessional velocity in an expanding universe. So he went on, it is interesting how the crumbling of one fundamental assumption can have reverberations throughout the whole underpinning of science. I have the greatest respect for that man. He was prepared to go wherever the observational requirements led him. The sign of a real scientist. This is the Hubble Ultra Deep Field of 2014, an exposure time of 600 hours. It's merely the visible part of what's pushing in on us. ARP showed that these faint redshifted objects are not distant objects necessarily. So even though this is a deep field, it doesn't mean that they're far away. This is just looking with very long exposure at things, the redshifted objects, and they are relatively close. They're mixed up with all of the bright nearby stuff. In other words, there was no Big Bang. I mean, the Big Bang was just a religious rewrite. So, astronomy has a massive problem. With repulsive gravity, collisions tend to be avoided. But the problem is for astronomy is that with attractive gravity, all you have is attraction, collisions, and explosions. That's why a Big Bang was necessary in the beginning. You'll notice in this picture too, there are no lightning bolts. That's a grave mistake. Is there a method to stabilise the chaotic nature of a many-body gravitational system? And this was alluded to also by Annis. What happens to orbits if we vary the mass of a planet electrically, remembering the dinosaurs and a sudden change? Well, as we've seen, and with the Birkeland currents and so on, we can transfer electric currents through plasma. And of course, the solar system is bathed in the solar plasma. And here the electric universe model meshes with the plasma universe and all of the peer-reviewed literature on plasma cosmology. Now, I've presented this in more detail, and it's available on YouTube, so I won't go into detail here, but the idea is to show that the radius of the orbit of a planet of mass, say M1, changes with the radius and the mass are proportional for a constant orbital energy. That means that if the mass of a planet via, say, an electrical discharge, thunderbolt of the gods, was to double, its orbit, the radius of its orbit would double, it would move out. And this is important because you can then establish order out of chaos. Now, in the case of Venus, they've already detected these stringy things, in other words, Birkeland currents, flowing between Venus and the Earth during conjunction there. In other words, that tail you see behind Venus has been detected by a spacecraft, I can't remember which one it was, many decades ago. I think this was back in the 1980s when it was reported. Now, in the electric universe, each planet is a small cathode in the solar discharge, and the electrons are actually transferred from Venus towards the Earth. It was the SOHO spacecraft, by the way. So the Birkeland currents transfer electrons from the inner planet to the outer one. The result is to increase the mass of the outer planet. Remember, the outer pole of those little gravitational dipoles is negative. If you add more charge, negative charge to that body, it increases the strength of that force. In other words, the mass of the body appears to increase, its gravitational field increases. But in this case, because of what I'd done in that earlier slide of high school physics, the outer planet will move away, get out of harm's way. Seems like a pretty good idea. So the tendency is for the orbits to change in such a way that this exchange of charge is minimized. Even now, when Mars is behind the Earth, they get what they call the blue clearing in the ionosphere of Mars, and those huge dust storms, all electrical effects. So the Earth still tickles Mars and Venus still tickles the Earth, but in prior times, during close approaches, those effects would have been far more powerful and marked. So stability is achieved rapidly, which was a requirement, of course, for mankind to survive. The important thing to recognize is that the electric universe model doesn't discard gravity. It does what Faraday wanted, to explain gravity in electrical terms. And so inertial mass equivalence is simply explained by this because it's all electrical. When you push an object, it's electrical repulsion, and gravity operates by electrical distortion of the particles in the same way. So it's simply because the effect of acceleration upon an atom is to produce the same offset of the heavy nucleus within the atom as does gravity upon an atom fixed in a gravitational field. So when you're falling, actually all of the nuclei in your body move to the center of the atom. You are weightless, massless, so to speak. This little video I enjoy because this raises the question about gyroscopes. The gyroscope spins the atoms in the periphery at many times the force of gravity. In fact, they measure I remember those centrifuges where they used to put the astronauts for training in higher gravity. All of the nuclei in the atoms of the astronaut's body will shift towards the periphery, and the same in a gyroscope. Now this guy, while he was Professor of Electrical Engineering at Imperial College in London, Professor Laithwaite was invited to give a Royal Institution lecture. He chose to demonstrate his observations on gyroscopic force, coming to a series of false conclusions on gyroscopic motion. The false conclusions this is taken from the actual report about this. These Royal Institution lectures used to be broadcast after the event. His weren't. And the reason was he came up with false conclusions. That's usually weasel words for he gave or performed an experiment which we can't explain. Now there are mathematical equations which appear to explain it, but it uses mass and acceleration and gravity and so on in those equations. And since they're not understood or defined properly, you've got to ask whether the mathematics really works. And the scientists were so uncomfortable with this demonstration that they prevented it being sent because it was false conclusions. These can actually be seen on the web at gyroscopes.org. But here's an opportunity to analyse gyroscopic motion from a new physical standpoint, and doing so may give clues to defeat gravity using materials science as well as physics. The offset of the atomic nuclei in a spinning gyro may be many times stronger than that induced by Earth's gravity, and of the opposite polarity, because here the outer part of the gyro is more positive. It's the positive end of the gravitational dipole. The experiment suggests the gyro becomes more strongly influenced by cosmic attraction than by the Earth. Watch this. Have we got sound?
I'll balance that, first of all, like a seesaw. So there is a balance point. When I take this out here, of course, then the balance point is upset. It should tip down. We know that given the opportunity, it's going to do this if it can, but now we've balanced it, and we've balanced it about its center of mass. So that if this gyro transfers its mass center to the pivot, it should stay balanced. The question is, will it? Let those who say I cannot make a body appear lighter than it is come and pull holes in that one.
Now, what I'd suggest here is that using the electric universe model is an opportunity for mathematicians to apply the electric universe model to try and explain that, because this gyro appears as a positive charge, if you like, in the presence of the negative charge of the rest of the universe and the negative charge of the Earth, and it seems to be more strongly influenced by the rest of the universe. Maybe this is why you can use gyroscopes for inertial guidance. They tie themselves to the rest of the universe. And also with these experiments, which show an apparent loss of weight, they may be better understood using the electric universe approach. So, electrogravity. The path since Faraday to the discovery of the electrical nature of gravity has been lost in the 20th century by a return to mathematical mysticism, assisted by computer-generated virtual reality. The path is regained, as Peter Modell, who I think may be here in the audience, he writes in his book, Making Sense. By describing carefully our experience of processes that deliver meaning, we can arrive at an understanding of what is involved. The intuition of the experimentalist Faraday should have carried more weight than later mathematical speculation, because he had the experience of electromagnetic processes that delivered sufficient meaning for the invention of the electric motor. Electric currents in plasma naturally form repeated rotating patterns of matter from galaxies to stars and rotating weather systems on Earth. Science needs to be simple. Resonant orbital systems of charged particles at different levels of scale within the atom may account for the nuclear force, magnetism, and gravity. That is, one force to rule them all. The electric universe suggests a repeated pattern of electric forces organising matter at vastly different scales. On the galactic scale, it's the long-range electromagnetic force due to Birkeland currents that dominates. Plasma cosmology empirically duplicates the galactic rotation curve in detail, and radio astronomy has confirmed, very recently, the spiral arm electric currents. It's the electromagnetic forces and the concentration of electromagnetic energy in the galactic core that gives rise to an apparent gravitational mass equivalent to billions of stars. There are no gravitational black holes. As you saw, it's repulsive inside an object. At the stellar and planetary scale, molecular forces form stars and planets and induce a weak gravitational field with a sphere of influence limited by nearby bodies and the repulsive force of the matter in the rest of the universe. By making earthly G a universal constant, we compute invalid masses for all other bodies. Being born in the same electrical discharge event inside molecular clouds, stars and planets will have much the same initial composition and structure, Sun included. Stars do not have a thermonuclear core because they too have Markland convected, and I won't go into detail here. It draws the matter in over a vast volume, and all of the heavy elements end in the core. So their radiant energy is due to reactions at the surface in the glowing ionosphere, driven by electric current from the galactic circuit. So this is an extension of Ralph Jurgen's model. The output of stars is not solely due to electrical input. There is something else going on. There are obviously nuclear reactions. So the complex beauty of the non-expanding electric universe is the result of electrical matter resonances and a balance between electrical attraction and repulsion at very different scales. Having a real physical model of the fundamentals, mass, energy, and gravity is the path forward. Looking back, it shows mathematics is a discipline, both ancillary and subordinate to natural philosophy, as physics was known before the 20th century. We are not within a grasp of a theory of everything when the real meaning of the symbols on the board are a mystery. We are not a few % contamination in a dark, unknown universe. Obviously, the architects of the electric universe were far more than mere mathematicians. The electric universe shows more clearly where the real mysteries of physics lie, in the ultimate nature and origin of charged matter itself and the electric force. As Etienne Klein and Marc Lachiez-Ray wrote in their book, The Quest for Unity, the telltale sign of a unification in depth is a more complete understanding of is a more complete understanding of elementary objects and a wider reach to other fields and objects of physics. Welcome to the real adventure. Thank you.